because I don't want to feel like I'm lecturing you unless it's a small crowd. That feels weird to stand in front of a small crowd. Um, but I want to talk about the future of WebRTC today. These slides are, I don't want to claim that I put them all together. I adapted them from slides put together by Dr. Alex Gouillard from Citrix. He published them out with Creative Commons, so I adapted them for today's presentation. But I was really excited because when he put them out, I was like, oh, this is exactly what I'm going to talk about next week, so this is perfect. So just a heads up, most of the stuff that I'll talk about today is still in progress. It's not, none of it is implemented by any browser, or not, none of the major browsers who support WebRTC, ORTC, whatever, have support for all of this stuff. Firefox is the closest in terms of WebRTC spec compliance. Microsoft is the closest in terms of ORTC spec compliance, and Chrome is the furthest in terms of features. But they diverge from the spec a lot. But it's all kind of, they all have plans to converge now that WebRTC 1.0 spec is kind of it's in the process of being finalized right now. So they're all hoping in 2016 to be WebRTC 1.0 compliant, which is cool. Follow these people on Twitter, me too, if you feel like it. By the way, these slides are online. I posted them on a meetup, so if you want to grab them later, do that. And these are the groups to ask questions on. WebRTChacks.com is great. They're always kind of up to date with the new stuff. And all of the people, all of the developers and project leads from these companies that are doing this work are kind of a part of the community, and they regularly post online their stuff that they're doing, and it usually ends up on WebRTC Hacks or some other blogs.
What's the main backbone of the community? Is it a Google group or?
Yeah, so Discuss WebRTC.
Okay.
The Google group is the primary.
That's right in front of me.
Yeah, no, it's kind of fragmented. That's the primary one that Google tries to use.
Okay.
I'm not sure what Mozilla does other than IRC.
Okay.
I know they have an IRC,
channel
specific
cool.
to WebRTC, yeah.
Cool.
And I don't know about Microsoft.
Okay, cool.
Yeah. So, okay, so to just kind of go over the current state, which is like what is spec compliant, but for a spec that never went 1.0. I want to go over all of that. So this is all stuff that's implemented in browsers as of late 2015, which is where we are now. So JSEP. JSEP is JavaScript. JavaScript Session Establishment Protocol. This is kind of the whole idea of offer answer, which you have to do in WebRTC next. WebRTC. So I want to create a call with another peer. I create an offer with my media types, my ICE candidates, all of that. I get some SD feedback. I send that over my signaling channel. They get it. They handle my offer. Then they add their streams, add their ICE candidates, do a create answer, send that back, and then I handle the answer. That's this, and it's terrible. Like it's not a good method to do, because we have, if we look at this, this is just kind of another view of this. You see these peer connections, these blue boxes down here, and there's a lot of stuff like bundled inside of there. So this is kind of an omnipotent peer connection. Like you have the three major APIs of WebRTC right now are Get User Media, RTC Peer Connection, and RTC Data Channel. 3 APIs for the amount of features that WebRTC offers is not awesome, right? Like, what if you want to do more stuff? What if you want to say, hey, let me negotiate, let me switch codecs, or let me pick specific candidates, or let me tweak whatever. You can't do that without mucking with SDP, right? Like and nobody wants to do that because it's not a JavaScript thing. You're basically just doing string manipulation of a giant blob of data. That's horrible. So, but that's what we have now. And it works pretty well. You can do stuff. It's hard to do some things. You can't do other things, but you can do multi-party video conferencing. You can do data channel stuff. You can have games. You can do file transfers, all that kind of thing. So the open questions are these kinds of things, right? How do you handle bandwidth preferences? How do you, Hello, this is Andrew. All right, I will come get you one day.
Hey, Andrew, what's us do again?
Oh yeah, if you wouldn't mind, that'd be cool.
Okay, I'll do.
You need a key, so.
No, you can't. I'm sorry. Anyone but you can. Yeah, apparently. No, you can't. Sure you're?
So yeah, how do you handle bandwidth preferences? How do you expect the fingerprints that you're using for data channels, which would be preventing man-in-the-middle attacks? How do you negotiate codecs? For those kinds of things, you can modify the SDP and kind of hope that it works, but maybe you get it wrong, right? Like that's and
What does STP stand for again?
STP is Session Description Protocol.
Okay.
It's what's kind of traditionally been used for telephony type stuff. Hey, look, okay, there's food around the corner, chips up here, help yourself.
Yeah, right around the.
Yeah, so STP, when you get it back, it's like if you ever Google like STP, it's just like this big bunch of lines of text that describe the connection, and that sucks to work with. So, but you can try, and you can do those things kind of by doing that. These other things, figuring out which candidate pairs are being used. So maybe you want to do some analytics and figure out how many of your calls are going over turn, or how many are host candidates, which is telling you, all my clients are in the same office or whatever. Restrict the ICE gathering. Maybe you only want to allow them to do turn calls, or maybe you don't want to inspect for public IPs in order to, not leak IP addresses for users that are primarily on VPNs, stuff like that. Getting information about ICE failures, speeding up ICE handshakes. Like none of this can you do right now, which is pretty limiting when you get into wanting to build really robust applications and systems, right? But you really need all of this stuff. So what's coming next is object model APIs. And feel free to interrupt with questions anytime. If I'm going too fast, let me know. So object model APIs is what ORTC stands for, Object Real-Time Communication, as opposed to Web Real-Time Communication, whatever. And they're going to merge. So they won't be separate. They will be together. So I don't know if they're going to prefer one name to the other or whatever, but kind of both APIs will live next to each other because they're really the same kind of things, same kind of end results, where ORTC provides a little bit more lower level control. Anything you can do in WebRTC, you can do in ORTC, but not necessarily the other way around. So the convergence, this is the big picture of ORTC. And did I link this? Did not. Yeah, but anyway, you can look at this more if you want to inspect the slides. But what you can kind of see is that there's no point in this picture compared to this one, where you have a single box that contains a whole bunch of things. And that's the goal for ORTC, is that you've really got access through your JavaScript APIs to all of these different things that you might want to do. You've got your tracks as opposed to a stream. So even that level, you're not just getting a single media stream, you're getting multiple media tracks. So audio, video. And if I want to change my camera and swap out the video track, leaving the audio unconnected, I can totally do that. You've got data channels that are multiplexed using DTLS, DSCTP over your SCTP transport, right? So RTP sender. So now instead of having a peer connection that you feed a stream and it magically sends RTP over UDP, now we've got an RTP sender. And that means that I can actually say, hey, send this media over RTP. Like that's low level control. And that's stuff that you can really get robust with. And then some of the other things with ICE. This stuff is like, honestly, when you're messing with ICE, you're doing some serious optimizations. I'm not going to be messing with ICE for a long time. I would like to get more information about failures, which is really cool. So from these different ICE transport controllers and listeners, I can figure out, what part of the whole process failed, but I don't have to interact with it in any kind of special way. Is everybody here familiar with ICE in WebRTC?
I'm not that familiar.
ICE is the process, it's interactive connectivity establishment. So it's the process by which you figure out IP and IP and port candidates for you to be able to establish a UDP stream.
Okay.
So when I say I'm available at this IP and port, I send that over to you. You can say, okay, I'm available at this IP and port, and we negotiate a connection. Yeah.
Okay.
And then this is just showing that it's mirrored on the other side. The difference being you've got an RTP receiver. Normally you'd have both, right? If you're doing a two-way call. So I can actually now separately say, here's my RTP sender that's sending out my media, and here's my receiver that's receiving it from the other end, and they're not all bundled in together. So why the object model? Everything only does one thing. Like that's a great kind of principle for software design in general, is that everything does one thing. You don't have monolithic functions or classes or whatever. Same kind of thing here. They don't want the monolithic API of the RTC peer connection. It does too much, and it doesn't give control to the developers. So having objects that do single things is the big goal. And then you can also inspect those individual objects for capabilities. You know, maybe Firefox has implemented RTP sender, and I can negotiate codecs, but maybe they haven't implemented ICE candidate filtering. I don't have to say, okay, I'm in Firefox version 47, so I think I can do these things. I can actually directly look at those objects and say, what do they support? That's a big thing. And then perimeters can be getting set dynamically in JavaScript. You're not saying, here's a big string of SDP, have fun. You're saying, this parameter should not be this, right? This codec should now be VP8, should now be H264, right? As opposed to grabbing your SDP, renegotiating the whole offer. It's just a big pain. So, so this is really great, but oh, I might get to this later. But anyway, but the big but here is WebRTC is also really great because it kind of is monolithic, and that's a little bit the opposite of what I just said. But the reason that that's good is when you have really simple apps and you want people to just really be able to spin something up with little to no overhead, WebRTC is kind of really great at that. You can say, I don't care about ICE, I don't care about codec negotiation. I just want to say establish a connection. So the WebRTC APIs are still valuable even with this object model. And there's kind of this debate going around. The original question was, is WebRTC too hard for front-end developers? Because it is kind of low-level stuff, right? You're dealing with RTP streams and you're dealing with fingerprints. It's normally not something you do in JavaScript in a browser, right? Like, and now they're saying, is ORTC too hard? And I'm kind of the opinion that we really should maintain both, because ORTC is hard when you want a technology to catch on with a massive amount of developers and have people start building apps on top of this. ORTC is a lot of stuff to learn. It's a big learning curve because you have to understand the entire process.
So what's the problem? Why not just put wrappers around it?
Well, that's totally what it is.
Yeah.
Yeah. So now you've got, and you can do that too. You can say, so some of the OTUC modules that I mentioned earlier. So Simple WebRTC is a library out there that kind of hides the underlying WebRTC stuff for JavaScript developers. So you can just kind of plug into it and go. It actually has audio only because of codecs support, but it has audio only interop between Chrome and Microsoft Edge. So that's a purely WebRTC implementation connecting to a purely ORTC implementation using the same library. So you can definitely do that. But it's nice at the browser level to say that we've got some higher level wrappers around collections of APIs, as opposed to having to include a library for that, especially since they've already been there for a couple of years. I think if they weren't there for a couple of years, it would make sense to just say, to put that burden on the community and say, if you want a higher level API, build a library for it. But because they've been there, it doesn't really make sense to take them away at this point.
Gotcha.
I think. Yeah. And I'll talk about too some of the ways. Actually, I think that's this. no, I have it somewhere, where they kind of add a couple new things specifically for the purpose of having them both. So I just wanted to show a couple examples of those APIs. So this is RTP sender. So when you actually want to send your media over and over a WebRTC, ORTC, whatever connection, you've got specific properties, right? A media stream track, DTLS transport, and another DTLS transport for RTCP. So this one would be for data channel, right? So you've got a collection of tracks and then transports for data channels. And then the methods replace track, get capabilities, and set parameters. Like it really, like this is a dream come true coming from WebRTC, where doing this kind of thing is a huge pain. And then one level deeper from that, DLS transport, you can specifically see what is the state of this object. Is it connected? Is it failed? Is it gathering? And then, or no, not gathering, that would be the ice gatherer object, which is a whole other object. But you get my point. You can kind of see the states of these things as they go and inspect them without jumping through hoops to do so. And you can event on specific objects too. So the open questions change now from what we had before. So the open questions before, some of this was you can't do it. Actually, most of it. So what we have now are, some of these things move up to, yeah, you can definitely do them. And there's a final API in place. And again, this is not implemented yet, but it's in the spec. So there's a final API in the spec for it. And then a couple things are going to, it could be better, right? So figuring out how to restrict ice gathering is still not, it still doesn't have a really clear final API. Looking at the current spec, it's not something that people have cared about enough to push for getting a final spec. Yeah.
What about trickle?
Trickle ice is there. That's part of WebRTC. That's part of kind of what's already been there. So that's definitely included. And I talk about that in a little bit.
Doesn't that speed up ice?
Yeah,
gathering?
it definitely does. It speeds up ice gathering from about 10 seconds on average to about a second on average. But what they kind of want to do is figure out how do we get from a second down to like 100 milliseconds, which would be kind of really ideal. So I'll show some of the ideas we have around that too. And then speeding up ice handshakes, that's something that's, you're relying on network stuff at that point. So, but there are some ideas for that. Okay, so this is a new API that is kind of new from both WebRTC and ORTC. It's called an RTP transceiver. So instead of dealing with a peer connection that negotiates all of your everything, or going to the other end of the spectrum where you have both a sender and a receiver, they came up with this idea of a transceiver. So it's kind of a sender and a receiver together. So you can really just look at your remote streams and your local streams in a single object. This is really going to be, I think, heavily used by two-way calling apps. I think it makes perfect sense for that scenario. It also
versus conference calls, or what do you mean?
I mean versus a call where you are kind of broadcasting.
Okay.
Yeah, where you've got media coming in and media going out. Yeah. So this addresses a problem with SDP, which is that in WebRTC there's two plans for the M lines, which are the media descriptor lines in SDP. There's the unified plan and there's Plan B. Plan B is where you have a single M line. I always get them backwards when I try to describe them. I know that Chrome supports Plan B. Firefox supports Unified Plan. Edge is going to support neither because it's going to do it's going to eliminate SDP entirely, which is kind of a noble goal, and that's what ORTC did because ORTC doesn't need SDP. You've got RTP senders, you've got RTP receivers. You don't need SDP at all. Um,
So you
and
don't need that big ass string with new lines in it with multiple parameters in it. It's
Exactly.
all real objects now.
Exactly right. So I don't know if they will adopt RTP transceiver. That'll be something we'll have to see. But it is a part of the 1.0 spec. So we'll see if they go with purely ORTC or if they go with the WebRTC 1.0 spec. But what kind of comes in is that M-lines and STP have attributes that don't really fit into. So when you're dealing with STP, that's where this is an issue, because you can't use STP and apply it straight to a sender or a receiver, because STP is intrinsically bidirectional. That's the kind of point of it, is it's describing the whole session from both outgoing and incoming. So it's got these attributes that don't apply to a sender or a receiver. It applies to a two-way kind of thing. But it also has, yes, it's also got properties that would then be duplicated, right? So you'd have the same parameters to set from your STP in your sender and your receiver. So it kind of makes sense to kind of convert to these in a way that can work with STP. So that's where the transceiver object came in, and it's trying to solve that problem of we've got STP supported applications or browsers, whatever. How can we gracefully give them an upgrade path? And that's this idea. It also happens to be very useful if you are dealing with non-browsers. If you're dealing with, say, a phone that supports WebRTC using STP, you could use this to talk to it. And I think we have phones here in this office that actually support WebRTC natively, which is pretty interesting. Although I don't think we'll ever use them for that. Okay, any questions? Does that make sense?
If SDT is completely eliminated, how will it going to fit in the telephone ecosystem? Because all of the SAFE and all of the Python applications, they all rely on SDT communication. So ORTC is implemented, or if ORTC is the way to go forward, how is that going to fit into the entire telephony ecosystem?
Yeah, so how that works is that you've got a middleman. So when the browser's talking, it's got RTP streams, and let's say it's purely ORTC, no STP involved. It's talking to some media server, some router, middleman server, whatever, for media. That is what's going to bridge that connection over to the rest of your telephony systems. So it might be doing SIP trunking, it might be doing call bridging to create large conferences, it might be sending it directly out to PBX, whatever. But the WebRTC call is not directly to the other end, which I think is what's key. And that has a lot of benefits. It kind of seems counterintuitive because you're like, oh, why don't I, if I can do interop directly, that would be great. But it doesn't, it ends up, to me, we find out that we have a lot of things that we miss anyway. So when you do that, so if we're going to use, let's say we're going to use SIP as our signaling protocol, use STP, do a WebRTC call, we could go straight to one of these phones. But we need to record these calls anyway. We need to support transfers. We need to, bundle audio streams. We need to do speech analytics. All of these things involve the media hitting a server anyway. So when you hit that server, you can then just relay those streams out to another system, and they can signal however they want.
Not to mention the network bandwidth requirement, the connection requirement. If you're going to a server, you can truncate all of that.
Yes. So this is kind of the subject of our last talk, was being able to do smart media things like last N and dominant speaker, where you're limiting the amount of streams being sent in a multi-party scenario. It has its benefits there too. So yeah, if your goal is to talk directly, say, to a SIP line, this is maybe more difficult. But I think that's why they're still trying to maintain those WebRTC APIs that let you do that. Yeah. Unfortunately, the Microsoft Edge
WebRTC APIs are not yet that mature to be completely integrated into the telephony systems. I mean,
right.
They are being currently done, but the flexibility is not that much. They have to maybe customizations.
Yep.
or write a lot of code to get that done. So WebRTC is there in the future, and if WebRTC is the way to go, then we're putting out a lot more effort in integrating these two systems together.
Yeah. Yeah, so that's the approach that we're taking here at Interactive, is that our WebRTC calls go to a media server. They never go directly to the other endpoint because there's all these kind of requirements
Or multi-party.
things that we're doing. Our browser video conferencing is different. All of our telephony calls
Oh, okay.
too, also, right? So any call from a browser that will end up at a phone is going to go to a media server first. Yeah. So, so talking about ICE. So to address your question, yeah, ICE is painful. You're basically saying, let me ask a bunch of servers what my IP looks like, and can I use it over this port? So a full ICE gathering process can take upwards of 10 seconds, and that's too long to establish a call. Right? You don't want to have to spend 10 seconds waiting before you even start ringing the other end. That's just unacceptable. So they came up with this concept of trickle ICE, which all the browsers support at this point, where ICE candidates kind of trickle in, and you use the best one initially, and it can recheck and renegotiate as it goes. But that still takes, a second, potentially even more. It's also really problematic on mobile. So if a mobile client is on Wi-Fi and you have a WebRTC call and you walk out the door and your Wi-Fi connection drops, you have to renegotiate all of that by gathering more candidates based on your cellular connection, and then renegotiate your whole stream. So,
Is that it?
Yeah.
So one thing that's always kind of confused me on that is, why do you need multiple opinions of your IP address and port? Why can't you just have one opinion, whatever the first one comes back?
that's kind of what trickle ICE does, but
Right, but-
network topologies change. So all of a sudden, Time Warner starts switching me through some other network path,
Mhm.
right? All of a sudden, my external IP, is different.
Well, and I understand doing that on like a reconnect, but on your initial connection, why do you need all those different opinions?
Yeah,
Because of that,
go ahead.
because of that, you're most likely your machine is not mapped to a public IP address. You're behind a router or multiple routers, and the first thing to do is figure out what are the possible exit points. And so once you have all your candidates, all the possible IPs and ports, TCP, UDP, then you can go and do what's called PICE negotiation handshake to figure out what's the exact media path without having to open holes inside your router, and open UDP ports, and all that kind of stuff.
Yeah.
One thing that I found doing this stuff is, most of the world will probably never be on IPv6. And so a lot of that, from a server perspective, I just disable IPv6.
We have it disabled as well.
Which reduces the number of ICE candidates that get looked up.
Yep. Yeah. And some other companies are doing some interesting things with ICE. Facebook Messenger restricts ICE gathering. They're not purely WebRTC. They have some kind of divergent pieces, but they kind of restrict ICE gathering initially to turn only, and they relay calls for setup. And then after the call is established, they will continue to gather candidates and potentially negotiate to server reflexive. And the reason they do that is they want the call setup to be nearly instant. And turn or relay candidates are almost always going to work initially, right? Because you're connecting to an external IP, connecting to a publicly available IP instead. Yeah, that's so kind of finding all these little hacks to do, kind of improving it has kind of been a big challenge.
So with that approach, Turn is very CPU heavy because all calls are being relayed through there. So I guess the logic is, Facebook will eat the CPU during the initial setup, and then behind the scenes do this additional stun lookup or whatever they're using,
Right.
and then kind of drop this tuck the turn signaling behind the scenes to free up the CPU, and then fall back to this peer-to-peer connection.
Yep, exactly. And I think they've said that the CPU is actually pretty light for Turn, but it's the bandwidth that's really heavy. If you've got 100 calls going through a Turn server, like you're sucking up
Just
your bandwidth.
proxying, right?
Yeah, yeah. It's taking media in and sending it out. So you're
It's not doing transcoding.
right. Yeah. So some ideas that the WebRTC groups have come up with to improve these things are really kind of application level things. Facebook's doing their Turn thing for doing calls at a time, but it doesn't really improve the ICE thing. But some of the ideas are start gathering before the call. So what if your application is sitting there? Maybe it's a chat application that can upgrade to video. You think the user might start a video call. You can use some heuristics to determine when that might be the case if you want, or you can do it all the time if you're okay with that. But start gathering ICE candidates. Maybe you even have an API. Maybe they even create an API in the future that creates an ICE pool. So if you register as an API, as a WebRTC compatible app, the browser will start an ICE pool, and it will just do that in the background. It'll gather ICE candidates and stick them in this pool that you can use. So when you start your connection, it's automatically going to say, here's a bunch of candidates, and it speeds everything up. That's something that they've been talking about, but haven't made any additions to the spec for that. Which is, pre-gathering in the ICE pool. And then they want to simplify pairing and checking. I can't actually speak to what that means. I haven't done a lot of research into that. But. Any questions?
Could you say you have an app and it's a push-to-talk app, right? Couldn't you establish ICE without media ahead of time?
Yeah, you definitely could.
As soon as somebody,
Yeah, exactly. You could kind of do this yourself ahead of time.
like preloading.
Yeah, preloading, exactly. Although, let me think about this. I think there's some challenges into figuring out how you'd have to modify your peer connection kind of on the fly, so because you're creating it without a stream or without media, and then you have to add media to it. So you'd have to do that, but as long as you haven't established the connection. And the only reason I bring that up is because renegotiation has been a challenge in browsers. But you're not actually renegotiating because you haven't negotiated yet. I think you probably could. I haven't seen anybody doing that. I haven't tried it. But I would love to see an example of somebody try that out. I think that'd be when you spin up, you create your ICE gatherer. It comes preloaded with candidates. That would be very cool. Some other improvements and ideas that they've been thinking about is warm up and async all the things. So don't make any part of the process of establishing a call synchronous. Everything can be started and use promise-based APIs to continue when other pieces that it relies on are ready. The warm up is similar to the ICE gathering and ICE pool concept is having things kind of primed and ready to go when your user initiates that call, so that things can just start up and immediately start. Another thing is having, so along those same lines, having ICE GTLS media all ready before the signaling. So if you have an app where maybe it's not an app that they initiate a call after, but they start it up and they want to immediately start a call, you can start requesting media before you have your WebSocket open for connections, right? Like, why not warm up and pre-start all that kind of thing. And then this one is interesting. I'm not really sure what the implications of this next one are, but start sending your media at the same time that you send your answer.
It's like early media.
Yeah.
Where you have like a ringback in telephony.
Okay.
SIP 183.
Okay.
Which is so when you pick up a call, you could actually send STD before there's an answer, before 200 OK.
Okay.
And in that response, you could start sending media like a custom ringback tone. It's what, like when you call like another country, you hear different rings because the
Right.
carrier sends early media, or when you call somebody and it's a toll-free call and they ran out of minutes, you play a prompt back without charging them or something like that,
Sure.
or an invalid phone number.
Yeah, I think all of that could be. I mean, that could be really cool. So I won't. I'm not. Don't want to pretend like I'm an expert on that. So that kind of stuff is. It's all kind of really new and to the WebRTC world. So, but I think taking some of those ideas that evolved from the telephony space over time and applying them is kind of the goal here. Is how do we just improve the whole thing without putting the burden of doing all of these things on the front end JavaScript application, right? Or whatever type of application it may be. So bandwidth is painful, just like ice, right? Everybody's got bandwidth issues. Hopefully around here we won't have them soon. Google Fiber is coming, but it will always be a problem. Once the U.S. is covered in fast internet, we'll still be talking to people in all kinds of other countries that don't have fast internet. So handling that is, I mean, when you're talking about multimedia streams, bandwidth's always the most painful thing. So handling these things with multiple streams, simulcast and SVC is the goal. So just to kind of go over what these things mean. Alex from Citrix calls this multicast. This is not multicast. This is something else. So I renamed this in my slides. This is multiple streams and tracks. So this is to say all of us are in a WebRTC connection. We've got a mesh network. I'm sending my media to everyone. You've got a bunch of streams. Everything's decoded separately. Bandwidth management is separate. Each of those RTP senders or peer connections, whatever it may be, is separated. The app is managing all of those streams and connections at the same time, and you've got lots of ports. All of that says bad things for your network. So simulcast is out to improve that. So what simulcast is that you're uploading, as opposed to uploading several streams tracks, you're uploading several tracks. So I'm connected to Phil. I'm going to upload high definition, low definition streams to him. Maybe it's only 2, maybe it's 5 different resolutions, frame rates, whatever. Phil can choose which one he renders or captures, whatever, or the signaling layer in the middle can determine that. They're decodable separately. Smart bandwidth as much as we can. It's still not great because I still have to upload all of those. I can't know based on what Phil's capabilities are. Maybe he's on a mobile phone that doesn't care about HD, whatever. So it's not really smart in that sense. But the app still has to manage all those tracks. And you do have reduced port usage with MUX and bundling, but only to a certain degree. So SVC is scalable video encoding. It's where you've got several tracks, but they have a single source. So now I'm not capturing multiple video. I'm not using get user media 3 times. I'm using it once. And I can use SVC to downgrade those. It's not decodable separately except the base layer, which means that's kind of a drawback in some sense if you want to do different things with the different layers. It definitely does smart bandwidth because it's determining what's the best based on the connection. Definitely uses less bandwidth and it has fewer tracks to manage. So SVC is coming. It's not in really any browsers yet. So there are apps that kind of do it. Things like video uses an SVC to downgrade its streams, but it also multiplexes streams. Kind of does some really heavy stuff with media that kind of really improves. But that's very CPU intensive and really expensive to run. I think I put this totally out of order. So basically, just I guess to sum this is that with multiple streams, you're managing all of that. With simulcast, you're just managing fewer in number of tracks. from the single source, and then as you see, is that downgrading is handled on the wire. It's not up to you to do that. Any questions about that? Or corrections? Feel free to correct me. Okay, that's it. I'm wrong often. And there's a bunch more stuff that's coming in the world of WebRTC 1.0 and after. Client recording, I think, has been added to Chrome already, so you can capture and record streams that are incoming. It obviously doesn't do anything with multiplexing if you've got a multi-party call or anything like that. You can do DOM capture. I think that's actually in Chrome. I'm less familiar with that API, but that's basically saying capture and stream my video from this part of my DOM, and that's really useful for a kind of word I'm looking for.
Screen sharing?
I don't want to say screen sharing. What's the term for these?
Co-browsing.
The co-browsing. It's more like a co-browsing thing because you can allow the user to say, yeah, I want to share my screen, but not my whole screen, not even my whole tab. I just want to let them look at this DOM, and you can use the DevTool style, like when you hover over it highlights what they're selecting, and you can stream directly from that page. And so it reduces, especially if you're on like a MacBook Pro with Retina, that's a high resolution stream that you're sending if you're capturing the screen. So you can really downgrade that by capturing the DOM and streaming that. So I think that'll be a cool API to play around with.
Even if it was just limited to Canvas, that would be pretty cool. Just if you could use the Canvas and render your own frames on the Canvas, every time it changed, it just kept sending it. I mean, that one's a little more flexible, sending any DOM element. But if you could just, even if it's just Canvas, that would be pretty good.
Yeah. So you definitely could use this with Canvas, is what you're saying?
Yeah, basically.
Better statistics. The get stats state, the state of get stats right now is abysmal. Chrome does a whole bunch of prefixed stats in there that are you have to inspect and spend an hour parsing through to figure out what stats you want. Firefox is closer to spec, but have fewer stats available. Do you have a question?
No.
So getting all of that kind of in line with the spec and saying, these are the statistics that are useful to be capturing on the fly, and let's unprefix the ones Google's got prefixed. Let's just kind of fix that whole mess. Data channels in Workers, I think, is a really cool one. Not for video chat style applications, but for things like pure CDN, where you're streaming CDN style resources over data channels. Having a really cool concept because it can preload things and figure out what your cache is before your app even runs, which is kind of awesome. It also has pretty cool implications for gaming, because JavaScript is single-threaded, but service workers, does anybody know, are not, because you can have multiple service workers that are actually run on different browser threads. Is that true?
They're still, we have to manage them coming back together. They're still evented, so when they get stitched together,
Okay.
they're single-threaded because they're event-based. That's how you get them back into. But
Okay.
yeah, when they're running individually, they're running the process.
Yeah, so you could have so you could basically do kind of interesting things with that. You could have maybe you're broadcasting a large amount of data to multiple users at the same time. Data channels can certainly do that, but it's going to be, because you're on, if you're capturing stuff and sending it, you're limited to the speed of the run loop. But if you could defer that to service workers, I think that you could do some pretty interesting things. But if you're interested in that concept, check out Pharos on GitHub and Henrik Jordag. They're both doing really cool stuff with service workers. So, security, there's also new stuff with security coming along. Things like the ICE gathering restrictions, being able to know smartly that the browser is on a computer limited to a VPN. Let's not leak public IPs, things like that, and kind of improving that whole layer. The fingerprint checking is also one. So you can do checking fingerprints end to end. You could actually encrypt the media in a way that
That requires a fingerprint sensor, though, doesn't it? I'm totally kidding. Bad joke. Bad joke.
yeah. I was like, but yeah. So sending, being able to do that would allow you to kind of encrypt messages sent over those data channels, not relying on the browser's encryption of it. Audio output devices is in Chrome. I'm super excited about that one because everybody asked me for that since day one that we launched our video chat app. They're like, why can't I tell it to send my audio to my headset? I'm like, because Chrome won't let me. But now we have that in Chrome 46, I believe. So that's exciting. And better screen capture APIs. The screen capture APIs are difficult to use and not intuitive. Unfortunately, I think that the changes they're talking about here are limited to the kind of combining screen versus window, because right now versus tab. So you've got these, you have to request the screen or request a window or request a tab, and that is irritating because the user has to kind of choose ahead of time. You have to have a button that says share your window, share a window, or share a screen. Chrome does that under the hood differently, but Firefox doesn't, in line with the spec. So getting that experience improved. Unfortunately, I haven't seen anything good in the way of the permissions and security around screen capture APIs. They're still really terrible. Chrome requires you to have an extension installed to do screen capture, and Firefox requires you to either have the user set a Firefox flag, or you can petition Firefox to have your URL or your domain added to their whitelist, which, like, neither one of those processes are anything that you should have to do for an API in the browser. Like, it's that's bad. So hopefully they improve upon that.
That was one question I always had with our screen sharing, is why it had to be plug-in based. And is it that, does WebRTC dictate the API for screen share, or is this like an add-on the browser getting stream?
My understanding is that the browser determines the security for those APIs, and Firefox does it through that flag or whitelist, and Chrome does it through the extension. I think that's terrible.
But I mean, do you request it via the JavaScript API and then that launches the plugin or checks
Yes.
these things?
So what you do is you message from your app to your extension. Your extension does the media request. No, sorry. You message to the extension. The extension gets a stream source ID from the browser, and then sends it back to you. And so it says basically kickoff screen capture API. It gets an ID. You message that back down to your app, and your app does a get user media with that source ID.
Okay.
And by having that source ID generated on the fly by the extension, Chrome's able to validate that that's one that the extension gave permission for, and it then launches that stream for you, or starts that stream.
So do you know of anything that's coming, or is that like outside the realm of the spec because it's left browser land?
That's my understanding, is that that's outside of the spec, and I really hope that they fix that. So, create issues on Google's WebRTC bug tracker. Like, that's the only way this stuff gets fixed, really. They do stuff, they prioritize heavily based on both spec compliance and user feedback. So, user feedback's a big one. So that's pretty much all I have. I'm very open to questions. I want to talk to everybody, but I appreciate you coming out. Any questions for me now at this point?
Anybody have any issues this week with Chrome 47?
What were your issues?
Web pages not over
HTTP? Yeah.
I had that happen on Chrome Canary for
Is that the insecure response thing?
your self-signed search.
Yeah, so-
weren't accepting.
So I'm working on
Not that.
Not that, okay.
Get user media won't work on
Non-SSL.
unless it's localhost.
Ah.
Or you put something in your host file and try to
Yes. So I am working on a post for WebRTCHacks.com addressing that specific issue because a lot of people have been having it.
They even tried to iframe it to work around it.
Oh, can't do iframes, definitely. Yeah, so your options are get an SSL cert.
I have an SSL cert. It's just the way that my startup works.
Mhm.
I don't have control over websites
Okay.
in some cases.
Okay.
So it's not as simple as saying like, hey, you need to get a cert. You need
Yeah.
to push all traffic over HTTPS.
So what I'm advising people is to switch to like if you don't have one or don't want to spend money on one, like go use Cloudflare. It's free tier because you can get free SSL with
You get
Cloudflare.
SSL certificate for $5.
Yeah, it's unfortunately that's what they're telling people.
Yeah.
You just don't have the option. But I don't have a lot of sympathy for people who've been into that issue because there was a console warning deprecation for about 6 months, and it was on all the discussion boards. But I understand a lot of people ran into it, or you had an app out there and it was living and you didn't think about it. So that happens. I totally understand that. So, but if anybody needs help with that, definitely ask the discuss WebRTC group. They're addressing that a month. Yeah. But yeah, that's been the primary thing is that people got hit by that new security requirement.
Is that the same thing that I ran into last week where I had to set a flag in Canary to allow insecure responses?
So you hit it because you were on localhost.
I was still doing HTTPS.
Yeah, but you were connected to a self-signed WebSocket.
Is that what it was?
Yeah.
There's also command line 2 flags that you can set to specify a particular domain to get around it.
Oh, there are.
Yeah.
For the okay.
Yeah.
I would be interested in figuring out what those are.
Sure.
To include in that post because I didn't realize you could just set a specific domain. So, yeah, and the tricks I think most people have been doing is forwarding ports from your local host to if you're working off of a dev box or something. I know the domain flag. I had heard that the domain flag was there, but I thought it had been removed. So that's good to know.
And also you could do your host file.
Yeah.
Put an IP in there. Create a fake domain name.
Yep.
Like a wildcard cert or accept the self-signed cert.
Yeah.
So with WebRTC, yeah.
Cool. Any more questions? We did some introductions earlier, but would you mind?
Sure. My name is Danny Hirschman. I moved here from New Jersey in February. I worked for a startup in New York called Cinchcast.
Okay.
It's basically large-scale conference calling. And then I'm also bootstrapping a startup with my boss, who lives in Austin, which is kind of interesting.
Cool.
Which is a WebRTC-based business model.
Okay.
So
awesome. Well, I definitely want to be in touch because I'm super excited to find people around here working on this stuff. My first couple of meetups were me talking to all these guys. So, yeah, awesome.
The large conferencing, are you guys using VideoBridge?
no, we're using FreeSwitch.
Okay.
We currently use a proprietary system. We're using, it's not WebRTC based, it's
Okay.
all telephony based,
Mhm.
and streaming for webcasting.
Sure.
So we used a legacy system called Pactolus. It uses a language called SIP with MSML. So it basically embeds like an XML language inside of info messages to do things like playing prompts, telling the media server to record.
Is that a blend of voice XML?
Yeah, basically, yeah.
Okay.
So you establish a dialogue in SIP, and then once the dialogue is established, you can send info messages. So it's kind of like you have SIP signaling, you have RTP, and then you have this MSML language, which is like kind of like its internal API. And all of this is happening on like a giant media chassis, kind of like a Blade server with individual media cards.
Okay.
It's called the Convidia Media Server by Radisys is the name of the company. So it's very monolithic and
Yeah.
Doesn't have like failover or
Right.
session, your media card dies, you lose all session information.
Sure.
So we just rewrote the whole system using FreeSwitch.
How's that been working? Good. Cool.
Scales really well.
Yeah.
Actually.
Um,
Better than Asterisk.
so we're approaching large scale conference calls with the Jitsi video bridge, which is the open source one. So we're kind of in our test stage right now. So yeah, see how it goes. But
Are you guys dealing with having single conferences on? I don't know I don't know much about it, but how do you guys deal with? Do you have single conferences on single servers, or are you spreading the load out evenly amongst your cluster?
yeah, so we're planning on doing that. We're not quite there yet. Planning on spreading the load out over the cluster, both allowing multiple conferences on a single node and having a single conference span multiple nodes is the goal. We don't have that there yet. The spanning multiple nodes.
What happens if you have a call on the server and that server dies? What happens to all those callers?
So we keep the call states in Redis. So the idea is that a new instance comes up, or we transfer to another node that's already up, and we just reconstruct that call on the new node.
So you do re-invites back, like renegotiation back to the peers?
Yeah. And what we want to do, because what we want to, and this is primarily what I talked about in my last talk. So if you are interested in watching that later, it's on YouTube. I can link it on this video. But what we want to do is both allow survivability of the call when the signaling channel goes down with limited functionality, right? Like you won't be able to mute your call or start recording or whatever because your signaling layer's down, and then pick that back up when you reconnect to a different signaling node. So that's that side failing. But when the media server, the video bridge side goes down, we just want to immediately reconstruct it, and renegotiate the call and have minimal downtime. That's our kind of plan. We haven't run any real big tests on that yet.
Some of the new features in FreeSwitch 1.6, I don't know if you've seen any of them,
Mhm.
but there's some pretty robust video features in there. And call failover is like baked in already.
Okay.
It's all, it's MySQL.
Yeah.
But all the information is stored there already.
Mhm.
So it works pretty well.
Cool. Yeah, I definitely want to take a look at it. We considered early on when we started this about whether we were going to try to use a platform, Twilio, FreeSwitch, whatever. But because we kind of are a telephony company, underneath we kind of want to do a lot of that stuff ourselves and provide our services as a platform too. So we won't do it in the same way, and our target market is completely different. But I think that was kind of the decision that we went with. So, but I love looking at what other people are offering. What's Twilio doing? Nothing with big conferences. Right?
Twilio is just doing too much. That's my opinion.
Yeah,
I don't know.
they're
It's hard to tell what they are.
they're in denial about large conferences. They say mesh scales. It does not.
I use Asterisk anyway, so they will never be able to scale.
And then there's blue jeans, stuff like that for other kind of things. But yeah, so I definitely would love to talk to you more about WebRTC stuff. So I want to do a hack night as opposed to I sit up here and talk night. So if anybody's interested in doing that, let me know what your kind of experience level is. If you're interested in doing that, who would be interested in doing that? Okay. It's okay. No, that's cool. And who's written WebRTC code before? Okay. All right. Cool. That's totally fine. So I will try to set that up. But in January, we're gonna have Perry and probably Dave, who's not here tonight, doing a WebRTC drone/car, one of the two, maybe both, via WebRTC on a Raspberry Pi. So that's the kind of talk. It takes it away from the whole let's talk about video chat apps and takes it more towards the Internet of Things kind of idea. So if you're interested, come out for that. And I think we are potentially gonna have one of these at Bandwidth's office. I think they wanted to host one, so we might do that too. But right now we've just been having them all here. But the hack night we can do here, or we could try to find a coffee shop or a restaurant with Wi-Fi and do something like that. If anybody's interested in that, I don't know what everybody wants to do, but we have decent internet connection here. And
You're here.
so
Yeah, people have their opinion, but most of you guys are here.
Yeah.
Save your trip. And
It's pretty
also,
convenient.
yeah, the possibility of internet being down in a place.
Okay.
But I'm offering.
You should
It
bring
was also to
your,
my house.
you should bring your Duke colleagues.
Yeah.
The ones that are working on the drone, see if they're
That
interested.
guy I'll bring.
cool.
Although
Yeah,
he's not a programmer, he's like a mapping 3D modeling expert. So I don't know if he'd be down.
Oh,
with it.
still. I mean, that's how
Yeah.
you get good ideas, right? Is bring people
Yeah.
who are doing other
I'd be up
stuff.
for it.
Um,
You got robots, you know.
I'm very open to feedback, so please send me an email, please leave a comment, whatever. But I will stop talking now. Thank you.
Cool. There's lots of food.
Yes, eat the food.
Eat all the cookies.